Welcome to Spring LIB.
Okay, so a ball is thrown upwards at an angle of 36 degrees from the horizontal. And so we want to know what its velocity will be at the very top. So at the very top, so what happens to the trajectory ball is something like this. The direction of velocity sort of plateaus so that it is the direction of the top, vt, is in the horizontal direction. So it will be in Vx. So the top velocity is totally horizontal. So Vt is basically Vx in direction. And so we just have to find the x component of velocity given the initial V naught that we have. So for part A, all we do is find velocity at the top, Vt, which is equal to V naught times cosine 36. Because if you have this angle and you have V naught, and you want to find Vx, V naught over Vx is actually cosine, or Vx over V naught is cosine 36. So that's or Vx over V naught, yeah, right. So that's adjacent over hypotenuse, and that is why we're using cosine theta here. And so Vt is just 8.5 meters per second times cosine 36, and so that is 6.9 meters per second. In part 2, we use energy conservation as the problem states we should, and so this means that we equate the initial energy to the final energy. So initially you have just the ball thrown, so we're assuming the ball is thrown from ground level so that there's no potential energy of the ball, and so all it has is kinetic energy, 1/2 mv naught squared. That is converted to potential energy at the top, which is 1/2 mvt, well, kinetic energy at the top, 1/2 mvt squared, the velocity at the top that we just found. Added to that is the potential energy, which is mgy, y being the height. And so we have to find y. We can get rid of these m's, multiply everything by 2, so or both sides by 2. So y becomes v naught squared minus vt squared over 2g. And so that's 8.5 meters per second squared minus 6.9 meters per second squared over 2 times 9.8 meters per second squared. And that gives us y, the maximum height of about 1.3 meters.